Hi, Nicolas.
Hello, Sylvain.
Vincent just explained me about the concept of accumulation and overspeed for the line efficiency. But how do you actually make up the accumulation?
Here we have the most common types of accumulation solutions. Let's start with the EQHC. This accumulation table is based on the so-called principle of mass accumulation. It means it can store a large quantity of product in bulk.
Okay, and how exactly does this AQHC work?
This AQHC is divided into two parts, the incoming chain and the outgoing chain. The incoming chain are moving toward the end of the table. The outgoing chain are going the opposite direction.
Okay.
Do you see this metal shuttle in the middle? This shuttle is mobile. It will move back and forth toward the end of the table when we want to accumulate products, toward my direction when we want to empty the table.
Okay, but I see on this concept that the products are kind of touching one another and pushed against one another. Isn't that a problem?
Indeed, you're raising a good point. The pressure between the product is existing, but still is quite low. We will run the system later on. I will invite you to pick up one can to see how smooth it is.
Indeed, the pressure is really light. Does this table run any kind of product?
When it comes to complex shape, fragile product, light products, when you want to preserve the integrity of the container itself because it has an important impact on the consumer experience, like in the spirit, for example, that's not the best fit.
Okay, and what else do you have to do that?
We have some so-called single-file accumulation solutions. Come with me, I will show you.
Okay, let's go. All right, I can see that it's much different from the mass accumulation we've seen before.
You're correct, but the working principle is very similar to the AQHC.
And exactly how does it work?
We move the shuttles, stretching the product flow to create some accumulation capacity. When we want to empty the table, we simply move the shuttles back to the inlet of the table.
Okay, so these are for the similarities, but then what's different?
You can see straight away the main difference. The products are accumulated without any contact between them. It means they do not suffer from any kind of pressure. It then makes it possible to accumulate product which can be fragile or with a complex shape. However, the accumulation capacity offered and the speed we can reach are less than with any kind of mass accumulation systems.
Okay, so I understand both solutions have their advantages and inconvenience. What if we could combine the advantages of those solutions, enabling to accept any kind of product, at the same time protect the integrity and provide high accumulation capacities and speed? Wouldn't that be great?
Indeed, that was our challenge when we designed the AQFlex.
Yeah, I'm most curious about it. And if you are as curious as I am, let's join us in the next video to review the AQFlex in detail.